So in this section, we're going to be talking about network security groups. Now, we already talked about the concept of virtual networks and how we create these networks. Inside of them are subnets, and running on subnets are devices such as virtual machines that have a network interface to get onto the subnet. So you've got virtual machine has a network interface. The network interface connects to the subnet, and the subnet is part of a overall virtual network. Now, these devices that are connected to a virtual network communicate with each other over these virtual network paths. The network security group allows us to specify which type of traffic is allowed and which type of traffic is blocked. It is basically an allow/deny metaphor for letting traffic pass over the network. Now, the network security group can either be attached to the subnet or it can be attached to the network interface. So if you think of this as being a tunnel, on one side is the virtual machine with a network interface. On the other side of the tunnel is the subnet as a whole. You can put your network security group on either side of the tunnel. It's still going to allow or block traffic traveling over that tunnel. So let's take a look at this in action. So we have a virtual machine connected to this default subnet. The subnet has this address range. Okay. Now, if we go into the virtual machine, we can see the network interface. The network interface actually tells us in this summary section that there is a network security group attached to the network interface. So this, in this instance, is attached to the network interface. And if we go back to the subnet, then we do not have any security group attached to the subnet. Okay, so in this instance, the security is on the virtual machine side. Let's go to the network security group. This was created when we created the virtual machine. So if we didn't specify it, it would create this new one for us. I'm going to go into it. Now, by default, the network security group has a number of rules. It splits the rules into inbound rules and outbound rules. So you can look at this as being traffic coming into the virtual machine over that virtual network interface card and traffic that's leaving the machine. Let's have a look. I'm going to go to the inbound security rules tab here, and we can look at them in a little closer detail. So this is the default configuration. I have not added any other rules into the inbound security of this virtual machine. So by default, it allows traffic to come from another machine running on the same virtual network. Okay, so any port, any protocol over this virtual network is allowed to come into the machine. So by default, two virtual machines running on the same virtual network are able to talk to each other. Okay, that makes sense. And also by default, if you have a load balancer running on this virtual network that is, sitting in front of a virtual machine, then that load balancer is allowed to talk to the virtual machine. So again, any port, any protocol, this is the load balancer situation. All other traffic attempting to get into the virtual machine is blocked. So this is the deny action. So other computers, the load balancer allowed, everything else blocked. What this means is if I was to attempt to RDP into this computer from my desktop here, then I should hit this rule saying deny all inbound because I do not have the RDP port open for inbound traffic. Why don't we go ahead and add the RDP port for inbound. So I say add. And what we want is the source is going to be any for now, but ideally we want a source to be our network or our computer specifically. So I could actually say I want only my computer. If I did, it got my IP address. So what is my IP address? I could limit the traffic that is coming inbound over this RDP port to my computer that is located at this address. If my ISP was to change the IP address of my computer, then this would stop working. I can also do this in a CIDR configuration, so I can say /24, and that will cover all IP addresses on this from 0 to 255 in this case. And what we want to is basically send traffic to any destination, so we don't have a specific computer in mind, although we could put the private IP address of or the public IP address of this computer, but we won't. And the question then becomes which port. Okay, so the port for RDP traffic is 3389. Okay, so that is the standard port for RDP traffic to go from over the network. RDP traffic is TCP. We might as well block off UDP traffic. And we want to allow RDP traffic. Now the priority works by the lowest number having the highest priority. So you'll see that the default rules are a very high number, 65,000 up to 65,500. And so we can set the priority. The default was 100. I'll set it to 1,000. And we're going to call this RDP traffic. And so if I was to add this rule, because we put a source IP address, only computers on my network will be allowed to RDP over port 3389 to any computer that is subject to this rule. And for now, this is again on the network interface card, so it's only that virtual machine that's affected. I can do the same thing for HTTP and HTTPS traffic. There's actually another way of adding this. This is set to the advanced by default. If I say a basic, then I can choose from a drop-down list for, let's say, HTTPS traffic, and you'll see that it fills the ports in automatically. And I can call this HTTPS traffic. We'll let that add. And similarly, we can do the same thing for HTTP traffic. Okay, so this is HTTP traffic. Now, if we were doing, this is for Windows, obviously, the RDP port. If we were doing Linux, we would have to add the SSH port, which I believe is 22, but don't quote me on that. So basically, now we've allowed 3 traffic sources. 2 of them are from any source IP address in the entire world, and 1 of them is just from the limited set of addresses on my ISP's network. Okay, so that's the inbound traffic rules. Let's switch over to the outbound. The outbound is basically wide open. Okay, so this rule is saying that from this computer, from this virtual machine, it is allowed to talk to any other virtual machine on the same virtual network, allowed, and it is also allowed to talk to the internet. So that is internet traffic. So basically any computer on this network and any computer on the entire internet. All other outbound traffic is denied. But what other outbound traffic would there be besides the internet and other machines on this virtual network? Okay. So maybe we would, if we would want to do VNet peering and have other computers on other virtual networks, but otherwise the outbound rules are pretty open. The inbound rules are pretty closed. Okay. So that's the basics of a network security group. We're going to look at assigning this network security group to other virtual machines and even to the subnet in the next video. So in this section, we're going to talk about resource groups. Now, resource groups are one of those foundational elements of the Azure Resource Management Model, ARM, and they're basically an organizational structure. So you can create as many resource groups pretty much as you need. And inside the resource group is the resources that you create. So you'll see in my AZ100 resource group, as I create a virtual machine, all of the related disks, network interface cards, the storage account for diagnostics, public IP address, the network security group, the virtual network. They're all, 7 different resources. They're all inside the same resource group. Now, as we've already seen so far, there are many different benefits to having things in a resource group. You can do, we're going to talk about policies in a second. We're going to talk about locks, being able to deployments happen at the resource group level, so we can then generate the scripts, the templates required to recreate this resource group off of the resource group level. We can do reporting, so in terms of the costs of a resource group is very easy to pull out. So resource groups are basically that type of organizational structure. So why don't we just create a new one here? So I'm going to go add, and I'm going to call it, AZSJD new. Now the resource group name does have to be unique to your account, and so you cannot create 2 resource groups with the same name, even if they're in different regions. Okay. So you'll see this has allowed me to do it, and then I say create. And it's pretty instantaneous that it's created me a resource group. Now, there are no resources in this group, and it doesn't cost me anything, so I can have this resource group sticking around, and it really doesn't harm me in any way. I can choose to add resources directly from that resource group level, although it's probably more common to add it from this plus sign here or from the marketplace. But we can add resources. One of the convenient things about resource group is if you do get into creating lots and lots of resources, that you can delete the resource group, and that will also clean up all of the resources inside of it. So when you're doing a lot of testing, keeping your resources into a single resource group makes it very easy at the end of the day to delete it and then realize that you're not going to get charged from it. Okay. Deleting the resource group is pretty straightforward. You actually have to type the name of the resource group into a text box in order for that delete to take effect. I'm going to go back to my other resource group. Now let's talk about 2 elements. The one is locks. Now the concept of locks is basically allowing you to place a lock on the resources inside a resource group so that you don't accidentally make changes to it or you don't accidentally delete it. You can also do this on a, basically to prevent accidents. Okay, so if you've got this resource like AZ100 resource group, I want to add a lock and I want to say no changes. And there are 2 types of locks. One restricts deletions and one restricts any changes. So if I put a read-only lock onto this resource group, and I'll say no changes, please. Click save. Now I'm basically restricting the contents of this resource group from changing. So let's show how that takes effect. If I was to try to add a new resource, and let's just say I want to add a web app resource, click create. You'll see that there is this red exclamation point next to the resource group. It says the selected resource group is read only. So I can't even create resources in the existing resource group because the resource group is locked. Similarly, if I was to try to change something, so let's say I go into one of my virtual machines and then I want to stop that virtual machine. It says, are you sure? I say yes. You'll see that I'm getting an alert saying that please remove the lock and try again. So I can't even stop the virtual machine, let alone delete it or basically make any changes to it without the lock on the resource group being removed. Okay. Now, just like anything, locks are role-based access control, and so you can control who has access to removing the lock. Now, there's also this subscription level view of locks. So when I go look at this subscription level view, I can see which locks I have, and my no changes please lock is viewable at that top level, right? So in this section, we're going to be talking about app service plans. App service plans are basically computing environments in which web apps can run. Now, when you're creating your web apps or your app services, you do get the choice of choosing an app service plan or creating the app service plan within the app service creation process. I'm going to create an app service plan without creating the web apps. So this is the hosting environment for web apps, but I'm not creating any web apps at the current time. So I'm going to give it a name, AZSJD New ASP. Of course, it runs in my default subscription. Yours would say something differently. You can put it into a resource group, and I'm going to create a new resource group specifically for this. You do get your choice of operating system. This is relatively new within Azure. Basically, Windows is the default, and that's what web apps have always supported. Linux is relatively new, but the Linux app service plan is more like a container environment. So the significant difference between Windows and Linux is that Windows app service plans do allow you some limited access to the underlying infrastructure, such as accessing the local disk, accessing networking, etc. In a Linux environment, it's actually a containerized environment. You have no access to the host operating system at all. You do not have root access to the container. So the containered environment is a little bit different than the Windows operating system. Now, when you're creating your web apps, you also get a choice of operating system, and of course, the app service plan has to support the same operating system that you're choosing when you're creating your web apps. Now, location does matter, of course. This is the regions of Microsoft Azure. Different regions are going to have slightly different capabilities. I'm going to choose East US 2. Now, pricing is where we get into maybe it's the most interesting bit of setting up a new app service plan. I'm going to go into it. You have three overall groupings of these. You've got your dev/test for less demanding workloads. You do have a production environment, and you do have what's called an isolated environment, which includes faster networking and a better ability to scale. Now, in this particular instance, this is not available for what I've set up so far, but we'll show you in a second the differences between the two. On the dev test side, we have two shared infrastructure options. One is free, so you can set up a free web app that never costs you any money. It does have severe limitations, such as only 1 gigabyte of memory and only 1 hour per day of computing power. So for a very low demanding workload, you might be able to run it in the free plan, but you wouldn't have any performance expectations of that. When you get up to the D plan, you are paying a little bit. This case is $12 a month. It's one of the cheapest options for hosting inside of Azure. But you get 4 hours a day of computing, which is quite fine for a lot of situations. And when you get up to the B plan, now you're looking at what's called Azure Compute Units. So in general, when you see this compute units, whether it's database or in web apps, this type of value, ACUs or DTUs, they're basically used for comparison purposes. So I'm going to go over to the production and we can see this in more detail. The standard plan, S1, has 100 Azure Compute Units. The P1 V2 plan has 200 compute units. So you can expect that the P1 plan has got to have about 100% more resources, and it'll be 100% faster, quotes and quotes, in terms of that comparison. So Microsoft's not telling you how much computing power it actually is, how many cycles you're getting, but you can sort of relatively see this could be 1 core of a server, and this might be 2 cores of a server. But they're not giving us that detail. They're just saying comparison-wise, this is 100, this is 200, this is 400, and this is 800. And you can expect the P2 V2 is half as fast and half as performant as the P3 V2. So we can sort of see this ACU concept. Now I'm going to switch over to the Microsoft web page on App Services. And if we scroll down a bit, we can see in a column format the differences between the free plan, the shared plan, so that's F1, that's D1, B1, S1, the P series, which are 3 of them, and isolate. On the free plan, you can have up to 10 web apps that are sharing that one environment. So think of it as a dedicated set of resources, well shared, but not but anyways, a set of resources that you can have up to 10 apps sharing. In the case of a shared environment, you're paying $12 a month. You can have up to 100 app services that are sharing that environment. Now, once you start paying into the basics or standards, there's no limits on the quantity. The disk space starts off pretty small in terms of 1 gigabyte, but then grows to 10, 50, 250, or 1 terabyte. Now, instances. This is one way that you can scale in a app service plan. Within the free plan and the shared plan, F1 and D1, there is no scaling, right? So you can't manually or automatically scale to any number. You get just the one instance. Once you go into the basic B1 plan, in this case there's no auto scaling, so you can manually scale up to 3 copies. Now keep in mind that each additional instance costs you money. So if you're running all 3 instances in the basic plan, you're running at 3 times the rate. So let's say this was $70 a month. I can change this to monthly. So in this case, it's $70 per month. If you were running 3 of them, that would be $210 per month. Okay. Now, when we get into standard, now we're getting into auto scaling. This allows you to have rules based on the CPU usage or other metrics that will increase the number of instances, and you get up to 10 instances. Okay, up to 20 instances for premiums, and then up to 100 instances if you're running in isolated, high performance, high security, advanced networking options, etc. So we can see on a table like this the comparisons between the two. So in this section of the course, we're going to run through the different options for scaling, monitoring, diagnostics, and creating of our app service plans. So in this section of the course, we're going to be talking about Azure Batch Service. Now, Azure Batch Service, as the name implies, allows you to upload batch jobs into the cloud and have Azure manage the execution. Now, a batch job is basically any job that needs to be rerun 1,000 times, 100,000 times, millions of times on different pieces of data. This could be examples such as simulations, weather predictions, rendering of a movie, etc. So anytime you've got lots of identical tasks that can be run in parallel, then you can consider building it as a batch job. And Microsoft will manage creating the virtual machines and managing the tens and hundreds of thousands of virtual machines required to execute them. So instead of having a single virtual machine that takes 48 hours to do a simulation and render a result, well, then you can use an Azure Batch Service, have that done in parallel, and perhaps in an hour to have the answer instead. Now, Batch Service requires a batch account. So in this video, we're going to create our first account that we're going to then use to log in to the Azure Batch Service. This is separate than your Azure subscription. Now, it chose my subscription by default and put me into a resource group. I'm going to let it stay in that resource group. We do have to give it a name, and see here that the name is fully qualified, including the region. And so this name has to be unique across this region within Azure. So I'm going to call this AZSJD Batch. Hopefully no one's taken that. Now, instead of running this in East Asia, which I'm going to scroll down here, we can see that it's identifying it here. Let's choose something a bit closer to us. So I'm going to choose East US. Okay, right there in the United States. Now, specify an optional storage account. For best performance, we recommend a storage account, a general purpose V2, located in the same region as the batch account. So let us go through that process of selecting a storage account. Now I do have my Cloud Shell storage, but I'm going to create a brand new storage account. I'm going to call it Batch Storage. And it's a general purpose V2 it asked for, so I'll create that. And I'll create standard performance, and we don't need storage redundancy, so LRS for this account. So we have our new batch account running in our subscription and a resource group. We've given it a name, picked a location, and it's going to create a storage account for us. Okay. Continuing on to the next screen, we do have a way of allocating the pool. Okay, so whether the batch service manages the allocation of all those nodes, or whether it's going to be in our subscription, that's a decision that needs to be made. We're going to leave the default here. Tags, just like creating a virtual machine, we won't set up tags. And now we can review the batch account. So we're signing up for batch service. It's going to create a storage account for us. I'm going to click create, and then I'll have a batch account that I can start to use. So this is our Azure batch account. It got created in the region that we created it. We have a URL that represents our batch account. And to me, this looks a lot like a virtual machine. We've got the overview screen, tells us a bit about it. And if we were to minimize this or scroll down, we can see some monitoring graphs right on the overview. Now, of course, the monitoring for the batch service is different than the monitoring for a virtual machine. So we're going to see tasks, nodes, failed tasks, and the minutes that it's consumed. These are more in line with what you care about when you're talking about running batch jobs. Okay, let's open this back up, and we're going to go into the quick start section. And we could, obviously download PowerShell to be able to do stuff like that. I want to look at some sample code, because as developers, looking at sample code is sort of one of the easiest way to try to understand what's going on. When you click the sample code from within that batch service, it takes you to GitHub. No surprise, the Azure Samples user has Azure Batch Samples repository. And so we can see, I'm going to scroll down so we can see the README file, that there are languages for .NET, Python, Java, Node.js. And it tells you a little bit about the prerequisites. You're going to need a batch account. You're going to probably want to use Azure Storage to be able to see inside of those of your storage account in order to upload the files and jobs that are needed. Batch Explorer will tell you in a visual way how your batch jobs are running. And Batch does support Docker, and so there's a separate area to go if you want to look at batch support for Docker. We just want to dip our toe into a little bit of code here. So I'm going to go into the C# directory. And again, this is a number of sample code that we can start to look at and play with. It's going to tell you Visual Studio is required, and it's going to basically build the samples by getting the dependencies, etc. How you configure your credentials. There's a configuration method. Tells you more about the samples. Now I want to get into the getting started one, because that's the obvious place to start, and we're going to get into Hello World. I mean, Hello World is an obvious first program you're going to run when any type of new programming situation. So here's a Hello World file. We could obviously clone this, download the code, load this into Visual Studio, compile it, etc. I'm going to go into the program.cs. And we can see here that it's a very short program. There's only 160 lines of code. If we look at the public class program and the main method, which is what starts up when the program runs, it really just sets itself up and runs this hello world in an asynchronous fashion using the wait method, which basically fires it off and it just goes into a wait state waiting for it to finish. Okay. The hello world task, the asynchronous function that gets called, does some basic command, console write lines when it starts, gets the credentials for the batch account. So remember, we created a batch URL, got a batch name. There's going to be a key associated with that as well. And then it's going to basically open up the batch client. It's going to create a job called Hello World Job. And it's going to submit what it wants to run and then await for the job to complete. So it's a very simple controller, basically, is what it is. Orchestrator. And so this is the job, submit job async. Coming down to submit job async method, creates the job, and it's going to create a pool. So we basically have to create the app world pool, get the configuration settings for that. We have virtual machine size that we want, the operating system, number of nodes, etc. That's all in the configuration file, which we'll see in a second. And the core of it here is that it's basically running a batch job that says, basically command line job that runs the echo command that just says hello world from the batch hello world sample. So each of the virtual machines, when we look at the target nodes and stuff like that, is going to basically run this command. It's going to just basically echo back a hello. And that's the purpose of hello world anyways. So that's pretty much how you interact with a batch job using code. So go into GitHub, find this repository under Azure Samples User and the Azure Batch Samples repository. You can fork this or clone it and basically start from there in terms of starting to interact with batch. There's a number of samples. We just looked at the whole hello world. If we want to do something more than just say hello, the next one up is this pools and resource files. You can certainly read through this README. It does a little bit more than the hello world sample. And number 3 extends from that. So we're getting sort of a gradual increase in the complexity. So go check out those samples. It's an easy way to get started with the Azure Batch. So in this section and some of the sections that follow, we're going to be talking about all the different ways that you can store data and files within Microsoft Azure. Now we can start by the simplest method, which is using storage accounts. This is where you can store blobs. It also has capacity for tables, queues, and files. Now we're also going to talk later about databases, which includes Azure SQL Database and even Azure Cosmos DB, which is a non-relational data storage. In this section, we're going to be talking about the storage account. Now, a storage account is used for a lot of different things within Azure. If you're going to create a virtual machine, you need a storage account in order to store that virtual hard disk and the files relating. When you create a function, as we just saw, functions also require storage account. Various resources will create storage accounts for you or have you select a storage account. We're going to create a storage account ourselves without any computing infrastructure in front of it. So I'm going to go into here and say add. Alternatively, you can go into the marketplace, find the storage account. We'll go and do that. Find the storage category, and the storage account is the number 1 item, either way. Now, like a lot of resources, storage account need to be put into resource groups. So I'm going to create a resource group, call it new storage. Now this resource group has to be unique to the region. I don't know why that went away. New storage. Resource group has to be unique to the region, and so it should be fine calling it pretty much whatever you wish. Now the storage account name. Now storage accounts by default are actually publicly accessible. You do need security keys in order to access it, but this is going to end up being a URL that's accessible on the internet. That's why the name must be unique across all existing storage accounts in Azure. So across all of Azure. That's why I like to use my unique prefix, the AZSJD. Now I already have a storage account called this, so I'll call it 2. Now the location. Now it makes sense that you want to store your files in a location that's closest to the people and applications that are going to use it. If you're going to have your applications running in Europe, then it doesn't make sense to have the files that those applications need in the United States. So keep your applications and your files close together. Those can be close to the users. Now, in a fully highly available and fast response application, you might have to put this into multiple locations. But for now, just choose the location that makes the most sense. Now, one of the first major decisions we have is this concept of performance. Performance is basically whether the storage account is going to be using a magnetic disk, the traditional spinning disk, which are hard disk drives. This is the lowest cost, and it also has a big capacity. So if you need storage that's going to be in the multiple terabytes, then you might want to consider standard performance. Now, premium storage uses the solid state drives, those flash memory. It's a lot quicker. So in terms of the read and write performance, is a lot quicker, a little bit more expensive, and the maximum capacity, it will not be as much as a traditional spinning disk. Now, in these times when you're dealing with virtual machines, then you might want to consider premium disks. Okay, so unless you have a really good reason to have standard, or price really is going to be a huge consideration, then my advice would be to choose the premium disk. Now I'm going to tell you about both of those options. Let's start with the standard storage. Now, for most of your purposes of creating a storage account, you're going to want to choose Storage v2. This will be, 95% of the options out there. Storage, general purpose v1, as the name implies, is the older model of storage. There are only a couple of use cases for why you'd want to store in v1. One of them is if you got virtual machines or other resources running in the classic deployment model, the ASM model. So Storage v2 only supports ARM, the Azure Resource Manager model, which is the modern way of deploying resources in Azure. The ARM, by the way, is the only model covered on the test, so you will never need to know much about the classic model or how to work with it. But in real life, if you've got to work with the classic model for any reason, you might have to go to the storage model. Now, the other thing for v1 is, of course, it is a little bit more economical if you're doing a lot of transactions. So if you are recording millions of transactions to your storage account back and forth, then the Storage v2 has a different pricing model. Okay. Now, finally, there are blob storage accounts. Now, blob storage accounts are very specialized and only allows for block blobs. Now, blob storage accounts basically have access tiers where you can basically make this blob storage account public. So if you want to have anonymous access to your storage account, which is generally a terrible idea in most situations, but if you really do need your website to use the blob storage account as the source of the images displayed to the general public, for instance, then perhaps you want to create a blob storage account just for those things that don't need access, okay? But Microsoft recommends a v2 for most situations. The next decision you have in terms of georeplication. So there are 4 types of georeplication: locally redundant, zone redundant, geo-redundant, and read access geo-redundant. Locally redundant is when you have basically data that is kept in 3 total locations within a data center. So let's say you've got we're here in central US, then Microsoft Azure is automatically, without us having to do anything, going to store 2 additional copies of our files. So even in the worst case scenario, when a particular data center goes down or the hard disk that is storing our files gets corrupted or dies, they've got 2 backup copies, and they'll automatically basically fix that for us. It's a self-healing system. You don't have to do anything. So by default, you get 3 total copies of your data in locally redundant storage. Now in zone redundant storage, it's basically an additional layer of what's called high availability or durability. So the data then is going to be stored in 3 availability zones. Remember, we were talking about availability zones in the virtual machine section. So this LRS is in 1 availability zone. Zone redundant storage is 3 copies stored in the 3 availability zones. Okay, so and the pricing is the same for LRS and ZRS. So you get that additional durability, additional high availability, and pretty much for the same price. Now, when you want to go into geo-redundant storage, that's the next tier up. There is an upgrade in terms of the cost. Then Microsoft's going to keep 6 copies of your data. That is the original copy plus 5 additional. That also means they're going to take your data outside of the region. So the data will leave Central US region into other regions in order to maximize this availability. Okay. Now, finally, the read access GRS, as the name implies, means that not only is the data stored in other regions, but you have access to it in a read-only fashion. So if you do want to have your primary data storage in Central Region and your geo-redundant storage, in Eastern Europe or something like that, and you want to be able to read that data, then you can have read access storage, and your application would have to implement the secondary URL for that in the cases of where it just needs to read. Now the access tier, basically in this case it's cool and hot. And there's another one called archive, but archive tier is not at the storage account level, it's at an individual blob level. Now hot storage is the default, and it just means you implementing the standard read and write and the standard pricing, the standard performance. Basically your data is available to you anytime that you need it, instantly. For cool access, basically you're going to you're basically promising Microsoft you're going to keep your data for at least 30 days there, and it's a little bit cheaper. It's going to cost you a little bit more to access it. So this is really good for like backups. This is where you do a backup, you put it somewhere. It might be a lot of data, so it'd be nicer to save a little bit of money, but you don't really need microsecond access to a backup once it's been backed up. You might need access to it in an emergency, but anyways, the cool access tier is basically higher cost to access, lower cost to store, and it's great for things that you're not going to access very frequently. Now finally, archive tier, which again is not shown on screen, is even more so. You're going to promise 180 days that you're not going to access it. It's going to take hours for you to get that data. So if you start to mark blobs as archival blobs, then you're willing to give you're willing to take 24 hours to get your data back, but that's your maximum savings. So we're going to leave the hot storage access for now. I'm going to pause the video. We'll come back and we'll continue on the creation of our storage account. Now in this section, we're going to talk about Microsoft's serverless options. Now the serverless options include things such as the Service Fabric, Azure Functions and Logic Apps, and of course there's serverless database options as well. But before we get too deep into that, let's just break down the various computing options and where they fit within the overall Azure map. If we go into the marketplace and we look at the compute tab, we can see the first 3 things that are being offered to us are what is called infrastructure as a service. So we can fire up a Windows server, a Red Hat Linux server, Ubuntu server, or other types of Linux options. And then we're going to basically have full control over those machines. In the case of a Windows machine, we'll have RDP access. In case of Linux machines, we'll have SSH access. And once we get into those machines, we can basically use them for whatever we want. We can install any type of code that the machine supports. If the machine doesn't natively support it, we can install all of the framework items that are required in order to get that to install it. So if you choose a Ruby application, you might need to install the Ruby code in order for your Ruby scripts to be run, etc. But you would have full control of those servers in order to do that. Not only do you have control of the servers, but they are part of your virtual network. You can put firewall settings either inside of Azure or inside the virtual machine. You can open ports. Basically, just as if you would have a virtual machine running in your on-premises environment, you have almost full control over that machine within Azure. What that means, though, is you also have the responsibility. So if you are to install a Windows server and then you are to open up all of the ports and do some fairly risky things, then it could come back that your machine gets hacked, and it would be entirely your fault because you were irresponsible with that. So with great power comes a great responsibility, as they say. So the infrastructure as a service option is the most powerful, gives you the most control, but also comes with the highest level of responsibility on your shoulders in terms of keeping your environment secure and keeping your code up to date and making sure all the apps that you've installed, when the security patches are out there, you go back and then you install the security patches, etc. It's a full-on responsibility in terms of you protecting these machines from the operating system level up. Now, Microsoft is going to protect their environment. They're going to, again, there's a basic level of denial of service, attack protection, there's, etc., some infrastructure options. You're not going to have those issues of your physical machines being compromised when Microsoft's in control of that. But you do have a responsibility for the virtual machines, essentially. So that's the infrastructure option. Now, if we go over to the web marketplace, we can see the next level up, which is platform as a service. This is the web apps and the app services within Azure. This counts a web app, API app. There is a function that also runs as platform as a service. So when you create a function, you can choose for it to be serverless, or you can choose for it to run within an app service environment, which is the platform as a service. So I should say at this point, there is no effective difference between a web app, an API app, and a mobile app. Years ago, you could have said that one allows you to do something and one doesn't, but all three types of apps historically are now called web apps. Okay. Now, this is the web apps are basically allow you to upload your code. You have to do a packaging operation, upload your code. There's a configuration that you either have to include or do within your web app manually within the portal. And basically, it's very much like just giving your code to Microsoft, letting them run it within the context of what you've chosen as your plan. And then you can set various settings, just like in IIS. You go into IIS and you can basically choose what to enable. Do you allow PHP? Do you allow Java, etc.? Okay, so it's just like basically IIS running in the cloud. Now you'll notice other vendors have web app options. So WordPress has one, Sitecore has one, Drupal, and Joomla. So you can basically get this as a platform as a service offering within Azure. So Microsoft's not the only vendor of platform as a service offerings, but you will not find non-Microsoft options on the test. So if you're studying purely for the test, you just need to know that platform as a service are all of the app services plus a type of function app. The function app is the hybrid that can be both serverless or web app. We should also talk about containers. Now, containers are growing. In the last couple of years, Microsoft's adding a lot more options. You've got your Kubernetes service, the full-on AKS that you can basically fire up a orchestrator and a bunch of nodes and call it a Kubernetes cluster. You can have a managed cluster, or you can manage it yourself. We also have container instances, which are sort of the quickest way to get containers running. You just it's like a web app for containers. You've got other options on the marketplace, so DCOS is Mesosphere, and Docker options, etc. Okay, so containers are growing. They're types of platforms as a service, right? Because you're just basically you're firing up a container and then you're putting code. But when you're creating a Kubernetes cluster, then you have you're basically in pretty tight control of those servers, how many got created, whether you want to turn one on, turn one off, etc. So there is a level of control when you're creating clusters. So finally, let's talk about serverless as the final option. Now, we already said that functions do count as serverless if you configure them as serverless. The other types of things are logic apps and service fabric. So if I go, let's see, if I can just go back to everything, but okay, I'll go to everything. So if we load up a function app, we can see Microsoft puts that in the web category, but I'm going to go and create a function app to demonstrate. Give the app a name, so call it new function app. Now you can see that this name is universal because it is fully qualified.azurewebsites.net. So I'm going to put my signature first 5 letters. You would choose your own first 5 letters, of course. Now when we get down to the hosting plan, this is what makes it either serverless, which is the consumption plan, or a web app which falls into an app service plan. So the choice of consumption or app service plan is the determining factor between whether something is serverless or a platform as a service. Why don't we go in the next video and create ourselves a function. So let's briefly look at the requirements of this exam, AZ203, Developing Solutions for Microsoft Azure. Now this exam was just recently announced as I record this. It's only available in English at the current time. It is live. There is no beta period for this exam. $165 US or payable in your local currency depending on your location. Now you can schedule the test right from the website. Go to the Prometric Center and book the test, or you can actually possibly take it online if you qualify for online taking of the test. Okay, if we scroll down, we can see that this exam is focused on Azure developers who design and build cloud solutions such as applications and services. So this is a developer-focused exam. As such, you should expect coding questions and a test of your actual capability developing for Microsoft Azure. If we look at the topics covered by the exam, it covers basically the entire Microsoft Azure platform from a developer's perspective. There are 6 major topics that go through this exam. Everything from infrastructure as a service, platform as a service, storage, security, monitoring, and basically connecting and consuming Azure services and third-party services, including serverless technologies, searching, API gateways, etc. So this exam basically covers the gamut of most of Microsoft's offerings. Now it doesn't cover stuff such as networking or media servers and things like that, which are more advanced and maybe things that you would expect from an operations point of view. There is an AZ100 series of exams that covers operations. Now, if you take this exam, the AZ203, and one of the operations or architecture exams, together it's going to get you a DevOps certification as well. So there is another certification you get for taking this plus some other exams. So in this course, we're going to go through these requirements basically one by one. You'll see sections of this course for each of the major sections in this syllabus. Okay, so we're going to start off talking about virtual machines, move on to Azure Batch Services and containers and so on. So we'll go through the requirements of the exam as Microsoft lays them out. I absolutely recommend that you use other resources and also practice as you're studying for this test. You should download Visual Studio if you don't have it. There's a free community edition. Get the Azure SDK and actually implement some of what you're learning. So as we're creating virtual machines, go ahead and create virtual machines. As we're using databases and other services, then you should go ahead and do those and use Microsoft.NET and other development technologies in order to connect to those services, understand how keys work, and all those relevant pieces. We're going to cover this as we go through this course. So sit back, get yourself a glass of water, download the Visual Studio, and let's get started learning about this AZ 203 Developing Solutions for Microsoft Azure exam. So let's talk about the AZ 300 Microsoft Azure Architects Technologies exam. As the name implies, this exam deals with the technologies of Microsoft Azure. We're talking about virtual machines, virtual networks, and all of the services, the hundreds of services that are provided by Azure. If you look at the way the Azure Solutions Architect role has been laid out by Microsoft, the AZ 300 exam is just one of the 2 exams required to get certified. If you get the AZ 300 exam, which is this course and this exam, and you also get the AZ 301 exam, which is covered by a different course, together, if you pass both of them, you get the Azure Solutions Architect Expert Certification. As you can see, the 300 exam covers technologies such as infrastructure, workloads, deployment of apps, securing of data. On the 301 exam, there are some more architecture-focused topics around strategy, migration, and identity, and things like that. So this exam, the AZ 300 exam, the technology-focused exam, is a mixture of topics across Azure. Now, if you've already taken and passed other Azure exams, you might actually be part of the way to having studied for this test. So that's the good news. The contents of this exam are not 100% unique across all the other exams. If you, for instance, if you've taken and passed the AZ 100 and AZ 101 exams, which is Azure Administrator, I estimate that you've got 50% of the knowledge already required to pass this test. Or if you've taken and passed the AZ 200 and 201 exams as an Azure developer, then you already have 30% of the knowledge required to pass this test. And if you've taken them both, then you're more than 3/4 of the way there. That's my opinion, at least. Now, as a solutions architect, one of your big jobs is to understand what components are required to be added to solution and be able to justify why they need to be added. So given a choice of hundreds of Azure services to choose from, what service do you choose to add to your solution in any given situation? When you need a database product, what database product do you get, and why do you choose it? So why would you choose that particular database style? Let's say it's Azure SQL Database compared to SQL Server in a virtual machine or managed SQL Server services. Let's look at the exam breakdown. Now this is taken off of the latest of the Microsoft exam web page. 25 to 30% of the exam deals with deploy and configure infrastructure. So that's just over 1/4 of the exam. Now, when you're talking about infrastructure, you're talking about the Azure Administrator track. And as I said, these topics are right off of the AZ 100 and AZ 101 exams. So we're talking about storage, virtual machines, virtual networks, and Azure Active Directory. Another 25% of the exam has to do with workloads and security. So if we're talking about migration, serverless, networking topics like load balancing, virtual private networks, and some security topics like RBAC and multi-factor authentication. And again, those are very similar to what's covered on the AZ 100 and AZ 101 tests. Then we get into the apps. So create and deploy apps is only worth 5 to 10%, so it's a relatively minor portion, but it is covered on the developer test. So if you've already taken those, this will be familiar topics such as web apps and containers. Again, a relatively small part of the exam. Also 5 to 10% is dealing with authentication and securing of data in transit and at rest. Again, that's a small part of the exam, but it is very similar to the topics covered on the AZ 200 and 201 tests. Now, the next section is called Develop for the Cloud, and it's up to 25% of the exam. It deals with message-based architecture and auto-scaling, and again, very similar to developer-based topics. So those are the topics of the exam. Let's get into the first topic. So in this section, we're going to talk about virtual networking in some more detail. Now, as we saw in the last section, virtual networking is sort of the backbone that allows resources to talk to each other in different regions or in the same region, and there's various technologies Microsoft is offering to allow us to do that. Let's start by creating a virtual network. If we go into the virtual network search box here within the Create New Resource, we can see that we're given the option of creating a virtual network. A reminder that we want to create Resource Manager resources only. I'm going to click Create. Now, just like most things, we have to give it a name. So we're going to call this New Net. The first big decision we have to make is this concept of an address space. Now, Microsoft allows us to define, because this is a private address space, we can use basically any IP address range that we want. The Internet authorities have reserved the 10 dot IP addresses for private use, so you will not find a public IP address that starts with a 10 dot. There are some other ranges like 192, 168, etc. But the 10 dot is the entire A block that's reserved for private usage. But this doesn't stop us. If we wanted to make this 190.0.0.0, we could do it because that's a private IP address, and there's no way any computer in the world will be able to connect to this virtual network because this is a private network. So I'm going to actually go ahead and do that. I'm feeling a bit emboldened by this. Go into my subscription. I'm going to create a new resource group for this. So let's call this AZ New RG 200. Right? Hopefully I haven't used that before. Put that network into a location. Let's, instead of West US, let's put this in Canada East. Each virtual network has to have one subnet minimum. Now a subnet, as the name sort of implies, is a part of the virtual network. Okay, so by default it's given the name default, but we can call that whatever we want, call that front end in this case. Now the subnet is going to be again a part of the overall address space. So I could choose the entire address space, and if I did that, it would be no more room for any other subnets, which is fine strategy if you know for sure that you're not going to need to add any more subnets to this network. The reason why you would want to add subnets is if you need to subdivide your network into tiers like front end, middle tier, back end, and you want to have firewalls protecting the tiers, so you can create an entire network that has pieces to it, and you can create different servers in each one and protect them through using network security groups and firewalls. So let's say we want to create a subnet, but we don't want to use the entire address range. This address naming scheme is called CIDR, and it's an alternative to what used to be like an A block, a B block, a C block, etc. The way that you can remember this is that the /8 block is basically the equivalent of what used to be called an A block. You can see Microsoft is actually listing out the range. So this would be 190.0.0.0 to 190.255.255.255, and they're letting us know that there are 16 million IP addresses in this range. So /8 is clearly a huge number, and hopefully we'll never reach as many resources that we possibly could. If I made this the /16, then the tip here reduces from 190.0.0.0 to 190.0.255.255, and now it's only 65,000 IP addresses. That's still quite a lot. So every time you add 8 to your slash, you actually go down to, now this is a C block. Okay, so basically we have this C block, which is the /16, And then we can basically say /24, which gets us down to only 256 addresses. If we did it like this, we would have room in this network for many, many other subnets. Okay, we can just go 190.1, 190.2, 190.3. That's fine with me. We can actually, if we reduce this by 1, it doubles the number of IP addresses, right? So now denial of service protection, basic is included for free. And basic denial of service protection is basically going to make it hard for people to send traffic to this in a malicious manner. If you upgrade to the standard plan, that's a paid service, and then it does more adaptive tuning. It lets you know attack notification. If you're expecting denial of service attacks, or this virtual network will be exposed to the internet in some way, you may want to consider standard DDoS protection. Otherwise, you go with what Microsoft considers basic. Service endpoints. Now, this is a pretty cool security feature. We can basically open up this virtual network to connect with some of the built-in Azure services exclusively. So I could say this network connects to Microsoft SQL Database, Service Bus, Key Vault, Cosmos DB, etc. And it basically is a secure channel between this network and that service that the traffic would not travel over the open internet. Without it, then the traffic that goes from these addresses into resources on this network will travel potentially over an open network. Also, we get this choice of opening up a firewall onto this network, and Microsoft will actually allow us to create a brand new subnet for this firewall, and it's basically going to choose the standard SKU, and there are going to be costs associated with this. So we're not going to do firewalls for now. So you can see it's very simple to create your first virtual network. There's no cost to it either if you didn't choose standard protection or enable a firewall. So I'm just going to click create. And as you can see, that only took 23 seconds for that to do that. Now, if we go inside of the resource, we get lots more options in terms of setting up our virtual network. Now, by default, we don't have any devices connected to it, of course. Go into the subnet section. We can see the front end subnet we created using /23 address range, which is 512 possible addresses from 190.0.0.0 to 190.0.1.255, right? So that's 255 address blocks. But you can see that instead of saying 512 available, there's only 507. There are 5 reserved IP addresses in every subnet. And so whatever the total number of IP addresses that you reserved, 5 of them are going to be taken away. This is important when you're using some of the smaller address ranges. So if you're reserving yourself only 8 IP addresses, 5 of them would be taken away and you would only have 3. So keep that in mind when you're doing the math on that. It's very easy to create ourselves another subnet. I'm going to click plus and I'm going to call this one back end. Now remember, we created the 190.0.0.0 range for ourselves, and we reserved 0 and 1 for our front end. So if I was to then make that also a 23, we would go 2 and 3 for this back-end subnet. Remember, 5 are reserved. Now we can see some more options in terms of choosing a network security group, which we'll talk about in a second, or defining a route table. Again, we have the same question in terms of service endpoints if we want to enable that, or this subnet delegation, which we could do as well, but we're all going to leave that to the defaults and click OK. Again, it should only take seconds, and at the time that I spoke it, it says it's created, and there we go. Now we have 2 separate subnets on the same virtual network that we can add resources into. And again, we can start to set different firewall settings, different security on these things. Okay. We'll come back in the next lesson and we'll continue with this. So next up, we're going to talk about another way of storing data within Azure, and that is through a proper database. If I go into the marketplace and I go under databases, we can see that there's a number of options that Microsoft is offering to us. Now, the one you might be most familiar with is SQL Server running within Windows. So this is a virtual machine, just as if you had a computer next to you with SQL Server 2017 Enterprise installed. There's many different flavors of SQL Server. You can also bring your own license if you have a SQL Server license and save some money that way. But basically, having SQL Server running in a virtual machine is perhaps the most similar situation you have to SQL Server running in your own environment. So if you're going to do a migration from the SQL Server running in your data center to Microsoft Azure, this would be the simplest approach, right? Just getting it up, getting a SQL Server running in a virtual machine, and then you do the data migration, and you are almost the exact same situation you were before, just running with a different server. Now, that might not be the best approach, and it's certainly not the cheapest approach, but it is perhaps the most familiar to you if that's where you come from. The version that Microsoft wants you to really consider is called Azure SQL Database. Now, Azure SQL Database is a database as a service solution. It basically looks and acts very much like SQL Server. There's a high percentage of compatibility. So if you have a database that's running in SQL Server within your data center, getting that migrated into SQL Database for 95+% of you is going to be basically no trouble at all. You're not using any of the advanced features that SQL Database doesn't support, and so you're just able to migrate your data, point your application to the SQL Database, and move on with your life. Now, SQL Database is a lot cheaper option. There are different pricing options, and we'll go over them in a second, but it actually does save you money compared to a virtual machine and all the costs associated with that. So when you're looking at this from an exam perspective, even from a real life perspective, you really should look at SQL Database as being the best solution for a lot of the situations out there. And really, the only situation that you need a SQL Server in a virtual machine for is something where you're like tuning the settings within a hair of its life, or you're really trying to squeeze out the extra performance on the CPU, and you've got that memory dialed into just the perfect amount. If you really do need to configure the hardware and the settings to that degree, then you might want to continue on with that. There are also some advanced features with collation and the way that it does full text indexing and things like that that SQL Server, a SQL Database doesn't necessarily support. Now, Microsoft also provides a managed version of this SQL database. So if we go through the SQL database route, you're going to do all the setup, you're going to migrate the data, and you're basically responsible for managing the performance. If the database, if you need more performance out of it, moving to the higher plan. Migrating between plans is super simple, and we're going to look at that as well. But the managed instance basically lets you to migrate the data and let Microsoft take care of the scaling of it, etc. We also have Data Warehouse for those data warehouse and reporting situations. Data Warehouse is designed to support, tons and tons of data, the size of the data. You're going to use something like a data lake to report into a data warehouse. A database pool is part of SQL Database. We'll cover that. Now, besides the SQL Server compatibility version, which is called Azure SQL Database, you'll see that there are 3 other databases that Azure provides that are in the same fashion with Azure SQL Database, but you can have MySQL Database as a service, PostgreSQL as a service, and now I think this is in preview, or perhaps it's available, MariaDB as a service. So if you're relying on any of these database types for your application today, and you want to migrate into Azure, other than having a virtual machine with these softwares installed, I think MySQL is also available as a web app. You can have them as a database as a service, a software as a service type product here. So in this section, we're going to go through setting up Azure SQL database. We're going to create our first database server and then the database inside of that. And we'll do something similar we've done with Cosmos DB and the tabled storage, in which we're going to start programming a little bit against it to show how compatible it is. The commands for dealing with this are the same ADO.NET that you've been using up till now. So we'll start on with the coding, but it won't be anything that you hopefully haven't seen before in other situations. So in this section, we'll talk about Azure SQL Database as a place to store structured data using relational databases. So in this video, we're going to talk about role-based access control, or RBAC. Now, the concept of RBAC is that you want to grant users the least amount of permissions that they need to get their work done. So whether these are service principals, which are accounts that are run by applications and not people, or whether you're granting access to people within your organization into your Azure resources, into your applications, you want to give them the minimum privileges. You do not want everyone to be an administrator. Okay? Now, if we go into our My Subscription here, so this key at the bottom on the left here, or you can go into All Services and find subscriptions in the first item. We're going to have a look at the permissions on my Azure account here. So I'm going to pick the only subscription that I have. I can minimize this blade. And what we want to do is we want to check the access that people have to my subscription. It's called access control. It's the second item here. Okay, we don't need that blade anymore either. Now we could certainly look up a person and see what their access is. Let's go into role assignments here. So we've seen that there is a number of accounts essentially that have access to my subscription. My main account is the owner of this and is obviously an administrator, and so this user account is the only user that I have access to this subscription. There are also some apps that have access to my subscription. CloudDin is a Microsoft company that handles billing. They're sort of like an external company Microsoft purchased, but they do billing and cost control for Microsoft, Amazon, and Google. So you can, look into that if that's something that you need. But they've asked for access to my account, and I granted it to them so we can sort of see that CloudDin has access to my account. But you do not want every single person who needs access to something, whether it's your subscription, whether it's a virtual machine, whether it's the application, to have full access to all resources across your account. And you don't want them to be able to even give access to anyone else. So let's go into role assignment here. And this is a different John Doe, but we basically want to find a person. So I have this second account here, Scott J. Duffy, and we need to, in this particular instance, give this Scott J. Duffy some type of access to my subscription. If I choose the role drop down, we can see that there are dozens of options built in. Owner is the most expansive. It basically gives you full access to everything, and you can even grant access to everything to other people. So it's a granting permission. Contributor does give you access to everything, but then you can't give anyone else access. So it's a more limited type of administrator. And reader, as the name suggests, is a read-only account. So if I just wanted somebody, we can see that CloudDin has a reader permission to my account because it really doesn't need to modify anything. It just needs to go and see my use of resources. Now looking at some of the other options, we can see backup operator, backup reader, billing reader, CDN, Cosmos DB, Data Factory, Data Lake. So a lot of the resources within Azure have more specific permissions. So if I wanted to say, you know what, I don't need to give this Scott J. Duffy full-on owner permissions to every resource in my account, nor contributor permissions, but I did want him to deal with SQL Server. Okay, so it lets you, this one lets you manage SQL servers, but not gives you access to them or change their policies. So it's a limited permission on SQL servers. The manager permission gives you access to the policies, but not to the servers. And the SQL DB lets you manage only the databases, but not the servers. So we can choose something like this, SQL DB contributor, grant it to my other account, Scott J. Duffy, and click Save. And now I'm basically giving a very narrow permission to the Scott J. Duffy account. So when this person logs into the portal and chooses this subscription, assuming that they have access to other subscriptions, they're only going to be able to access the SQL databases themselves and not the policies, the servers, any other resource group, any other things within that. And so using this method, we can give people very narrow access. And that is sort of the recommended approach on role-based access control. Now we also have the ability to create custom roles. So if this SQL DB contributor is too vague, or we want to sort of mix that up with backups and a couple other things, then we can create a custom role so that this user only has access to those resources. So this is the concept of role-based access control. You're going to find this throughout Azure. So whether you go into your subscription, or you go into your Azure function, which is an app service. It might be a great example if this is... So if we go into, let's say, the storage account as an option, we can see there's an access control tab right off of, so almost every resource within Azure is going to have this kind of access control. And then we can see who has access to this resource. It's the same as going to the subscription at this point, I guess. And then we can check to see who has access to this object, and we can add people's access to it, etc. And even block them specifically. So access control is done through this access control, and it's on almost every resource within Azure. So in this section, we're going to be talking about Azure Site Recovery, particularly around migrations. I'm going to go into all servers, and I'm going to say Site. You'll see that Recovery Services Vaults is one of the options, and so I'm going to select it. I don't currently have any Recovery Services Vaults. Now, Azure Site Recovery is, as the name implies, a disaster recovery tool. Now, if you've got a set of virtual machines either running in Azure or running on premises or external to Azure, you can use Azure Site Recovery to have basically a replicated version of your application, multiple virtual machines, and your data ready to go in case a disaster happens. So let's say you do have your on-premises VMs, and for whatever reason, your internet service provider fails and you no longer have connectivity to the internet. You can basically initiate the failover. If you've got your Azure Site Recovery running and already replicated, ready to go, you initiate the failover, and then you'll basically deploy your entire application into an Azure region and get that booted up, and then you've got your application with up-to-date data ready to go. Now, this is a manual failover, but it is something good to have in place in case of a disaster. And if you discover that your applications are no longer responsive and you are giving up hope on being able to fix it quickly, being able to turn on the failover and then within 15 or 20 minutes have it up and running again is a pretty good outcome. Okay, it's not instantaneous failover, but it is a short-term failover. Now, you can also use the same technology for migration. So the same process of replicating your Azure VMs or your on-premises VMs in this case, basically you can initiate the failover and have that replication live within an Azure region, and you can set that up as your primary application from that point forward. Okay, so initiation of a failover is basically what makes a disaster recovery situation into a migration. So we're going to go ahead and create our first recovery services vault. Now, one thing to keep in mind for a recovery services vault, especially when you're using it for emergency recoveries, is that you basically want the vault to be in a different region than you're basically going to replicate from. So let's say you've got US East region, US East 2. If your virtual machines are already in East US 2, then basically having your recovery services vault and your virtual machines in the same region means that when the disaster strikes, that your vault is offline as well. So make sure that in the case of disaster recovery, that your recovery services vault is in a different region. In the case of an on-premises migration, then I guess it doesn't matter. You may want to have your recovery services vault physically close to your data centers, so that the data doesn't have far to travel and presumably goes over the quickest path. So AZ SJD new ASR. That's going to create me a brand new recovery services vault. We're going to let that run. So in this section, we're going to talk about some identity security services, particularly multi-factor authentication. Now, what is multi-factor authentication? Now, one of the big challenges with security these days is that people have user IDs and passwords, and no matter how complicated your password is, if it's 16 digits, contains letters, numbers, symbols, capitals, and funny foreign letter characters in the same password, if that password gets lost, someone breaks into your computer and steals it, or something becomes easy to guess, etc., that allows somebody to log in as you and basically be able to take over what it is that you have control over. So a user ID and password is not entirely secure simply because it can be lost. Now, when you add another factor to it, then that becomes even more secure. In this case, when they're talking about multi-factor authentication, it's either having a device, whether it could be your phone, or in the old days they used to have key fobs with randomized numbers on them, or it could be a fingerprint or an eye scan, etc., retina scan. So the multi-factor authentication refers to having more than just your password as a way of authenticating. And that's why it becomes more and more common for you to require your phone, and either you get an SMS message, you get an email, or you get a randomized number in an application that you have to type in order to log in just beyond your password. Now, Microsoft Azure Active Directory does support this. Either you have to pay for it, so it is available as an add-on service. It costs $1.40 per month per user, so there is a billing model associated with that, unless you're a premium Active Directory user. So if you are running on a premium plan, then it is included in that plan. Now, how do you turn on Active Directory? So in this particular case, I go into users. Now I have a mixture of native users, Azure Active Directory, and invited users. Invited users in this case are B2B. These are Gmail accounts in this particular case. Email went out to them, they accepted, and they are part of my Active Directory, but they are not Active Directory members because their email address isn't a controlled domain. So we have this new user and guest user concept. So once I'm in the users section of my Active Directory, you'll see it says multi-factor authentication at the top. When I click this, it's actually going to take me out of the portal into a separate website. So I'm going to zoom in a little bit, and we can see it is a Microsoft website, but it's basically completely different than the portal, and it's opened in a new tab of my browser actually. Now, out of my 5 users, remember 2 of them are actually Active Directory users and 2 of them are Gmail users, which are B2B. So I can actually only enable multi-factor authentication for 2 of those users. You can't enable it for users that are not part of your Active Directory as native users. So I've chosen the two of them, and I can click Enable. Now it says about enabling multi-factor. Basically, they're going to have to sign in through the web browser in order to sign up for app multi-factor authentication. If they access your services through their app, through some other method, might not actually work. So here's a link to how these individual users, Joe Green and John Doe, can sign up for MFA. But I control them, and so I can actually enable multi-factor. So now I've enabled multi-factor authentication on 2 users in my account, and that's basically how easy it is. Now, if I remember this is a separate tab, I can close the tab, go back to the portal. Now keep in mind that there is an impact on the support basically for your Active Directory. So now that you've got users that are forced to use multi-factor authentication, what you're going to end up with doing is people have their ID, they have their password, but they don't have their phone. Their battery has died, they lose their phone, or they changed their phone number, but they didn't migrate their multi-factor authentication. So there is another point of support once you make it more complicated for people to log in. But remember, security is not about convenience. Security in some ways is the opposite of convenience, because the more convenient you make something, the less secure it generally is. You're going to have to introduce things like this, having to have your phone to answer an SMS text or an app in order to log into your system as a way to increase security. Now, other compute technologies also have their own way of doing monitoring. If we go into a function service here, a function app, we can see I've created a little timer trigger, just a very simplistic, does nothing. Every 5 minutes it's just going to execute this log information. But where does this log information get stored, right? So let's go into the monitor tab of the function, and you'll see that the one thing we need to do is turn on application insights in order to capture those logs. So Azure Functions now supports application insights as the preferred monitoring solution for apps. Okay, so we do need to configure application insights for our function in order for that stuff to get captured. Now we have to create a new resource. This is our function app, East US, or select an existing resource. We're going to use our existing function app. This is the previous one. Okay. So now it's creating the application insights specific resources for this function. All right, so now I've turned on my function and turned on the application insights aspect. And it just gives me this simplistic view of requests coming in, failures, and how long things are taking to execute. And maybe this is a good way of seeing your live function, the life of it. Okay. So we'll see how to utilize that in a second. But right now, turning on the tracking and turning on the logging is sort of one of those key aspects of making sure that your function you can view the reports on that after the fact. So in this section, we're going to talk about virtual networking in some more detail. Now, as we saw in the last section, virtual networking is sort of the backbone that allows resources to talk to each other in different regions or in the same region. And there's various technologies Microsoft is offering to allow us to do that. Let's start by creating a virtual network. If we go into the virtual network search box here within the Create New Resource, we can see that we're given the option of creating a virtual network. A reminder that we want to create Resource Manager resources only. I'm going to click Create. Now, just like most things, we have to give it a name. So we're going to call this New Net. The first big decision we have to make is this concept of an address space. Now, Microsoft allows us to define, because this is a private address space, we can use basically any IP address range that we want. The Internet authorities have reserved the 10 .IP addresses for private use, so you will not find a public IP address that starts with a 10 . There are some other ranges like 192, 168, etc. But the 10 is the entire A block that's reserved for private usage. But this doesn't stop us. If we wanted to make this 190.0.0.0, we could do it because that's a private IP address, and there's no way any computer in the world will be able to connect to this virtual network because this is a private network. So I'm going to actually go ahead and do that. I'm feeling a bit emboldened by this. Go into my subscription. I'm going to create a new resource group for this. So let's call this AZ new RG 200. Right? Hopefully I haven't used that before. Put that network into a location. Let's instead of West US, let's put this in Canada East. Each virtual network has to have one subnet minimum. Now a subnet, as the name sort of implies, is a part of the virtual network. Okay, so by default it's given the name default, but we can call that whatever we want. Call that front end in this case. Now the subnet is going to be again a part of the overall address space. So I could choose the entire address space, and if I did that, it would be no more room for any other subnets, which is fine strategy if you know for sure that you're not going to need to add any more subnets to this network. The reason why you would want to add subnets is if you need to subdivide your network into tiers like front end, middle tier, back end, and you want to have firewalls protecting the tiers, so you can create an entire network that has pieces to it, and you can create different servers in each one and protect them through using network security groups and firewalls. So let's say we want to create a subnet, but we don't want to use the entire address range. This address naming scheme is called CIDR, and it's an alternative to what used to be like an A block, a B block, a C block, etc. The way that you can remember this is that the /8 block is basically the equivalent of what used to be called an A block. You can see Microsoft is actually listing out the range. So this would be 190.0.0.0 to 190.255.255.255, and they're letting us know that there are 16 million IP addresses in this range. So /8 is clearly a huge number, and hopefully we'll never reach as many resources that we possibly could. If I made this the /16, then the tip here reduces from 190.0.0.0 to 190.0.255.255, and now it's only 65,000 IP addresses. That's still quite a lot. So every time you add 8 to your slash, you actually go down to, now this is a C block. Okay, so basically we have this C block, which is the /16, and then we can basically say /24, which gets us down to only 256 addresses. If we did it like this, we would have room in this network for many other subnets. Okay, we can just go 190.1, 190.2, 190.3. That's fine with me. We can actually, if we reduce this by 1, it doubles the number of IP addresses, right? So now denial of service protection basic is included for free, and basic denial of service protection is basically going to make it hard for people to send traffic to this in a malicious manner. If you upgrade to the standard plan, that's a paid service, and then it does more adaptive tuning. It lets you know attack notification. If you're expecting denial of service attacks, or this virtual network will be exposed to the internet in some way, you may want to consider standard DDoS protection. Otherwise, you go with what Microsoft considers basic. Service endpoints. Now, this is a pretty cool security feature. We can basically open up this virtual network to connect with some of the built-in Azure services exclusively. So I could say this network connects to Microsoft SQL database, Service Bus, Key Vault, Cosmos DB, etc. And it basically is a secure channel between this network and that service that the traffic would not travel over the open internet. Without it, then the traffic that goes from these addresses into resources on this network will travel potentially over an open network. Also, we get this choice of opening up a firewall onto this network, and Microsoft will actually allow us to create a brand new subnet for this firewall, and it's basically going to choose the standard SKU, and there are going to be costs associated with this. So we're not going to do firewalls for now. So you can see it's very simple to create your first virtual network. There's no cost to it either if you didn't choose standard protection or enable a firewall. So I'm just going to click create. And as you can see, that only took 23 seconds for that to do that. Now if we go inside of the resource, we get lots more options in terms of setting up our virtual network. Now by default, we don't have any devices connected to it, of course. Go into the subnet section. We can see the front end subnet we created using /23 address range, which is 512 possible addresses from 190.0.0.0 to 190.0.1.255, right? So that's 255 address blocks. But you can see that instead of saying 512 available, there's only 507. There are 5 reserved IP addresses in every subnet. And so whatever the total number of IP addresses that you reserved, 5 of them are going to be taken away. This is important when you're using some of the smaller address ranges. So if you're reserving yourself only 8 IP addresses, 5 of them would be taken away and you would only have 3. So keep that in mind when you're doing the math on that. It's very easy to create ourselves another subnet. I'm going to click plus and I'm going to call this one back end. Now remember, we created the 190.0.0.0 range for ourselves, and we reserved 0 and 1 for our front end. So if I was to then make that also a 23, we would go 2 and 3 for this backend subnet. Remember, 5 are reserved. Now we can see some more options in terms of choosing a network security group, which we'll talk about in a second, or defining a route table. Again, we have the same question in terms of service endpoints if we want to enable that, or this subnet delegation, which we could do as well, but we're all going to leave that to the defaults and click OK. Again, it should only take seconds, and at the time that I spoke it, it says it's created, and there we go. Now we have 2 separate subnets on the same virtual network that we can add resources into. And again, we can start to set different firewall settings, different security on these things. Okay. We'll come back in the next lesson and we'll continue with this. So the next requirement of this exam is to talk about virtual machine backups. We can see on screen that the Microsoft Advisor is actually recommending that we enable virtual machine backups. And so we're going to go ahead and do that. We saw in a previous section that we can go into the Azure Recovery Vault, and there's a way to enable backups from in there. But we're going to go into this virtual machine. So we've chosen one of our virtual machines previously created. And we're going to go down to Operations, and we're going to go into Backup. Now, we can see here that we can either create a new Recovery Services Vault or select an existing one. Since I don't have a Recovery Services Vault currently, then I'm going to have to use this one. And remember, the Recovery Services Vault has to be in the same region as the machine is backing up. because you don't want that data to be traveling so far around the world. I'm going to put that into the vault. I'm going to put that into this resource group. Now, one of the key concepts of backups is the backup policy. There is a default policy, daily policy, but you can always create or edit this policy. So I'm going to go into the create screen. And we can see here that there's a policy named daily policy. Let's try, well, for this virtual machine, we have the choices of daily backups and weekly backups. So let's call this daily policy 2. And we're going to remain a daily backup, but we're going to want the backup to happen at 8 p.m. Okay, so I'm going to choose 8 p.m. I'm also going to make it 8 p.m. in my time zone. So go down into here and say Eastern time. And we can now also choose how many days we want to retain. So in this case, it's offering up the 8 p.m. backup will be retained for 180 days. That's quite a lot of backups. Let's change that to 90. We can also retain one backup per week. So when we're doing backups of virtual machines, oftentimes when you set up your backup policy, you want daily backups. Let's say you want daily backups for 30 days. But then you also want to keep one weekly backup on Sundays. So we can then keep, that's 12 weeks, which is what, 3 months. So we'll keep the daily backup for 30 days. We'll keep a weekly backup for 3 months. And then we'll do a monthly backup on the first Sunday for a year. Okay, so now we have just one backup a day that's happening, and we're going to retain different levels of them. Okay, and then I won't set up the yearly backup. So I can say OK to this. So now we have a daily policy that has daily, weekly, monthly backups that are retained. Okay, simply clicking Enable Backup at this point will modify this deployment, make sure that the virtual machine has the backup extension, and will create a brand new recovery services vault for us, and again do the backups every day at 8 p.m. So the Azure portal actually makes it pretty simple to set up these backups. I'm going to cause a backup to happen, and then we're going to show you how we can then restore from these backups. So come back for that. So welcome to the AZ 101 Microsoft Azure Integration and Security Exam Preparation course. My name is Scott Duffy, and I want to thank you so much for checking out this course. This course covers the AZ 101 exam. AZ 101 is one of 2 exams that are required in order to attain the brand new certification, Microsoft Certified Azure Administrator Associate. You get this lovely badge for passing both exams. You require the AZ 100 and the AZ 101 exams together in order to attain the Administrator Associate level. Now you can bypass that if you've already passed the 7533 exam. You should not be taking this exam, and instead you should be looking at the AZ 102 exam in order to achieve the same certification. This course is on the AZ 101 exam, and this course is going to be based on the official exam requirements. So Microsoft has a landing page that covers the requirements of this exam, and in this course I'm going to go through those requirements one by one. I'm going to cover everything that you need to know in order to pass that test. So thanks again for checking out this course, and we're going to get into the exam requirements right up next. So in this section, we're going to be talking about virtual machines. Now, virtual machines is one of the 3 pillars of cloud computing infrastructure as a service. You've got virtual machines, you have storage, and you have networking. So we're going to talk about virtual machines. Now, as the name implies, a virtual machine is a computer, a server, that looks and acts and behaves, for all intents and purposes, like a real machine. It would be very difficult for you if I was to remote desktop into an Azure virtual machine for you to determine whether this is a real computer running in a server room near you or whether it's a cloud-based computer. There are subtle differences, but for the most part, you can install anything you want in the virtual machine. You remote into it using either RDP for Windows or SSH for Linux. And it's a server. It's a Windows machine. You can install software, set things up. It looks and acts like a real computer. Now the benefits, of course, we talked about this earlier, are that you can get this machine for only as long as you need it. So if you need a machine for 20 minutes, you can create it, use it for 20 minutes, shut it down. You're only charged pennies for that virtual machine during that period. Now you can't just arbitrarily create any combination of CPU, memory, and storage availabilities that you want. Azure provides just over 120 different configurations that you can choose from. These are called instance sizes. Now, not every region of the world contains every instance size, and so if there's new instance sizes that get released, sometimes they come out with V2 of things or more powerful machines. You might have to go to specific regions of the world for that. Okay. That 120 plus virtual machine sizes get categorized into what are called instance types. And so in this video, we're going to review the different instance types. The first one we'll talk about is the most common. It's called a general purpose instance. Now, as the name implies, it's basically a balanced computer. It's got an even distribution between CPU strength and onboard memory. It's good for development. It's good for testing. If you've got a medium or low traffic web server or a very basic database server, not something that doesn't have very strong needs in one of the categories, this could be a very good generalized computer. There are 5 different instance types, instance sizes within Azure. There's the B series and the D series, DS, A, and even DC. Now these, you're not going to be expected to memorize these labels. It's not going to be on the test in terms of knowing, but things like B, D, and A are so generalized, so common, that you should understand the relative strengths between them, right? The B series are literally development servers, not necessarily good for production. The A series are low-powered servers, and then the D series are even higher powered servers, and these things are priced accordingly too. So when you go into the create screen, which we'll do in the next video, you're going to see a relative difference between the price of B series, A series, and D series. But these, if you see these labels, then you know that this is a general purpose computer that is designed to be fairly even between the different elements of CPU and memory. Now, this is opposed to what's called a compute optimized type. This means that the CPU has a high CPU but not as high memory. Now you could save some money as opposed to trying to get a balanced computer that is high on both CPU and memory. If you have applications that are batch computing, application servers, something where the CPU speed and CPU, the number of cores, is important, then the compute optimized might be the best solution for you. This is the F series. It's F or FS within Azure. That means compute optimized. Now on the other side, you got the memory optimized. So this is where the memory is high, but the CPU is not necessarily high. Again, there's a lot of letters relating to this: the E series, the M series, the G series. There are some elements of the D series, which we talked about in the general purpose, which is also to be considered as memory optimized. So whereas D series is generally general purpose, at the upper levels it gets to a memory optimized server. This is good for database servers, caching servers if you use Reddit, any type of analytics that does a lot of work in memory. So memory optimized servers are good when you need lots of memory, but the CPU isn't as important. Finally, there's also storage optimized. Now, we haven't talked about storage till now, memory and CPU being the two features, but if you really have intensive I/O tasks on the local disk for that machine, high disk throughput, high I/Os per second, then this might be the one for you. This could be for database servers, data warehousing, large SQL servers, things like that. This might be where storage speed is the overwhelming factor that you're concerned with. That's the LS series. Now the S in all of these types usually stands for SSD, right? The solid state drives. That's a faster type of type of storage. Solid state is a lot lower latency than typical spinning disks. So there's only solid state option for the storage optimized. Fifth up is the GPU series. Now, sometimes you have modeling, you're doing intense machine learning and other things where there's a lot of GPU functions, maybe even Bitcoin mining or running blockchain functions. So the GPU series is really provides graphic processing, video editing, video rendering, things like that. That is the N series. So if you see the letter N in the front of the name, that tells you it's a GPU server. They break it out into whether it's compute optimized or memory optimized, plus the GPU, so NV, NC, and D. Finally, the last type of compute is called high performance compute. And this is really for those instances where you really need a massive computer. These are going to be expensive. On your default account, you're not going to be able to even reserve these without getting Microsoft to approve your account. It's going to be limited to the regions of the world, but it's the H series. So the H series has not only high throughput, everything is on a special fast network, right? The RDMA network, which is not what most virtual machines are on. So those are an overview of virtual machines, what it's good for. Coming up in the next video, we're going to go and start creating one. So let's get into the Azure portal and create a virtual machine. So in this section of the course, we're going to be talking about the automation of the deployment of virtual machines. Now within Microsoft Azure, the automation of virtual machines is usually done using ARM templates. As you know, ARM is the Azure Resource Manager model, which is the modern way of organizing and deploying resources into Azure. The opposite of ARM, of course, is the ASM model, which is the classic deployment model, which we don't use anymore. So when you do a deployment of a virtual machine, you usually get a screen like this saying your deployment is complete. Now we can see, if I actually go back to this particular resource group, we can see that I've done many different deployments to this resource group, but we're going to focus on the virtual machine one. Okay. Now, one of the options we get when we're looking at deployments is to look at the template. The template consists of two items. There's the template and there's the parameter file. We could download the template, which I'm going to do, and we're then also want to download the parameter file. Now, the scripts that are being presented, the CLI, PowerShell, .NET, and Ruby, only exist so that we can execute this template. These are not the PowerShell equivalents of the template. They don't replace the template. They basically require the template. Let's look at what has been downloaded. So I'm going to click it to open it. And if I bring it back into frame, you can see that it's got the template, the parameter file, and it has a PowerShell, a CLI, Ruby, and some C# code in order to deploy it. So there's 4 different methods to deploy it built into this zip file. We're going to open up these files and we're going to look into them, and we'll try to explain how an ARM template is organized, and to the requirement of the exam, how do you modify the ARM template. So here we can see inside the template.json file. Remember, we have both a template and a parameters file. Now the template JSON file is in the format of a JSON file, of course. The first property is the $schema property. This schema refers to the deployment template.json URL, and that's a required field. Now the version number is a version number that you can control. So you can see here that Microsoft gives us version 1.0.0.0. But if you wanted to check this into a source repository if you wanted to use this template as the baseline for your environment and then make changes to it, you can increment this version number so that you'll know which file is the most recent, etc. There's also a parameters file. There appear to be about 20 or so parameters being passed, and we'll review them when we get into the parameters JSON. Variables are similar to parameters, but you can see that these are basically computed fields. So the deployment template is actually taking a resource group function and the name of the resource group this is being deployed in, and constructing a virtual network ID based off that. So this is basically a area where variables are constructed. They're not input from external. The key section here is the resources section. Now this is where all of the resources within this deployment get defined. We're going to look into that in a little bit more detail in the next video. I'm going to scroll down here. The last section is the outputs. And so once everything's been created, this ARM template is going to be able to return the admin username as its output, even though that's a parameter that's being passed as input. But this is the verification that this works. Okay, so this is the basic overview of what an ARM template looks like. If we flip over to the parameters file, we can see that there's going to be one parameter for each of the parameters defined by the template. So the template has a location parameter, which is a string, and in the parameters file, the location is being sent to Central US. Now, the way that it's got these values is that when we created this resource within the Azure portal, we chose Central US as the location. Azure portal created a new virtual network interface name for us, and we accepted it. We could have changed it, and that got set into here as well. So all the values in here basically come from our selections, our choices, as we were creating the resource in the portal. Now, that's the basic overview of the ARM template. In the next video, we're going to look at editing this and then being able to do deployments based on our edits.